Hello again. Today we'll try to find out where this tree band tone control is focused. If we have this audio band, let's say 100 Hz to 20 kHz. So I want to see exactly where are the peaks, the equalizer or the tone control it's working properly. I couldn't find any other way but to inject different frequencies and measure the response of the controls. So let's start with a very deep, let's say 30 Hertz. And we got on the screen 30 Hertz. The base potentiometer is 0. We take it off and we have a value here of minus 34 dB with minimum. And then if we go to max, we have 11.32. Let's say so easily. We can say that we have a plus minus of 34 minus 11, that means 23 dB. Yes, 30 Hertz. This is very effective. Let's go a little bit higher. Let's go to 50 Hertz. So we are on 50 Hertz and the lowest point is 32.13. Okay. And the highest one goes to minus 13. Something like here. Somehow we are getting lower values than 30 Hertz. Okay, let's go to 90 Hertz. We have a value here, minus 28, and the higher one, minus 17. Okay, let's go to 150, minus 25, and minus 20. So we are almost out of the range. Minus 220. Okay, look, 250. Let's try this. Nothing. At 250 we are out of control. Minus 21. Okay, this is interesting. At minus 20, subsonic almost minus 10 here. Let's say minus 20. And the other one down here. But this is great, people, because we can get rid of minus 35. We can get rid of the subsonic frequencies. All right, I may say the bass, it's working from, let's say, from 20 Hertz to around 200 Hertz. Let's check that out. 200. Oh, we still have a very small reaction here. Minus 24. 24 with minus 21. So this is very clear. We may say that 20 Hertz to 180, maybe, let's see, 180. We still have a little bit of, yeah, this is okay. The bass working from 20 Hertz to 180. The middle is somewhere around 100 Hertz, let's see. But the maximum amplification, it's funny. It's around 30, even lower than 35. Let me see, 10 Hertz, 11 Hertz. Ooh, very interesting. Okay, so that's the band. Somehow I can say there is the middle point frequency. No, it's working like a frequency cutting filter more. The frequencies under 100 Hertz, they are dramatically cutted or amplified. So everything here is in dB, of course. I don't have too much signal at the input. We are only reaching minus 18. I can go higher, but I don't want to touch anything because we already have a kind of reference. All right, that's for the bass. Now let's go on mediums. So let me start with 200 Hertz. 200 Hertz. The bass is absolutely out of the question. We cut the medium. Okay, and we have minus 27. Okay, and plus minus 18 here somewhere, minus 18. Then we go to 200 and okay, let's go to 300. And we have a 300. We have a minus of 28 here somewhere, minus 28. And the plus of, we are talking about medium now, minus 17 here somewhere, let's say, minus 17. 400. We have a plus of minus 17, same, and the minus of minus 29. Very close. 500 minus 29, same. So we are almost the same in this region with a top minus 16.93, a little bit higher, minus 16.9. So in this area we don't see too much difference. It's almost the same. 29 point at 600 we have even lower, minus 29.5 to minus 1694. Same story. This goes like this, up and down, almost linear. We don't waste our time here. Let's go to 1000 Hz. We have a minimum of 29.5, same, with a maximum of minus 17. Let's go straight to 2000. We have a high gain of minus 18, kind of change. So I think we are starting to go back, minus 18 and down. Oh, come on, minus 28.5, 3 kilohertz, minus 27.6 with amplification at minus 18.5. Okay, 4000, still working there, minus 19 here somewhere, and down here minus 26. Okay, so 29, 29, 29, 28, 28. Okay, this is here, minus 27, it's going here, and then we have minus 26, minus 18, minus 18. So I think we are going to the end of the band here. 5 kilohertz. We still have minus 25, minus 25 with minus 31. Okay, 6000 with a top of minus 25 and minus 31. Same story. From here it's constant. We got something under minus 18 with minus 26. Minus 18 with minus 26. Let's say 100 hertz. Is it going there? A little bit. So somehow it's going to the base. Minus 26 with minus 21. Yeah. So from here it's getting very narrow like that. So this is funny. Somehow around 4.2 kilohertz or something, we start having this shape. So the mediums are going, let's say, from 200 hertz to around 4 kilohertz with 28 around maybe plus minus 10 dB, something like this. That's the shape for the mediums. Okay, let's go to the high frequencies, and here we're gonna have anything from, let's say, 6000. The high frequencies are going even lower, of course. Look there, 2000. Let's start with 2K. I'm just taking the numbers, I am not following any specific order. Let's start with 2K. Yeah, we have a minimum and a maximum here, minus 25 with minus 31, like here. 3K, we have a minus 31 with minus 23, 23.8. Let's say 24. Okay, then we go to 4000 hertz. Sorry, minus 31 with minus 22. Somehow at the bottom it's pretty constant for now. Okay, minus 5. Okay, let's go to 6000. Minus 32 with minus 19. I think I read it wrong, something here. 5000. Let's go back. Minus 31 with minus 20, of course. 7000. Minus 32 with minus 18. So we have an amplification there. 9000. Minus 32 with minus 16. You see, it's going up, and here a little. It's the same story. It's cut filter. 10,000. Minus 33 with minus 16. Minus. Now let's go to 15 directly, and we extrapolate. There we go. Minus 13 with minus 34. 18 kilohertz. Okay, so we have a minimum of minus 18. Minus 35 with minus 13. So here it's pretty steady now. Minus, I said 18, minus 35 with minus 13. Okay, so it's kind of this shape. You got the numbers on the screen. I may say the maximum value here, it's around, maybe around 12 kilohertz. 16 is going up, so somehow it's starting from 2 kilohertz to 20k with 1633. The average, I think it's plus minus 15 dB, something like this. Okay, now we have a single test to do. That was the frequency test. You got the recording anyway, so you can, let's see where the amplifier or the corrector, it's cutting the signal. How much is the signal and how much is the limitation. And now I'm going to use the sound card output, because it's capable of a really big signal, to apply that signal to the preamp, to the 3-tone control input, and we're gonna have a voltage RMS over there. Oh my, so 2.97 RMS and still running great. I don't see any problem. That's the input, of course, and let's see the output. So I can't see it on the computer because I'm using the desktop now like a sound generator. So we have to use my other little oscilloscope. You know, these guys, they are very useful, I can tell you that. And to check the output of the things. Okay. So we have at the input almost, let's say, 3 volts RMS. Okay. And at the output we have 2.2 volts. There is no amplification. This is very clear, but with all the knobs on 0. You see that the high treble, are moving the signal up. So okay, let's open all of them. Okay, all right, so here we have a limitation when I'm pushing the mediums. So with all the controls at maximum, I can say that you can apply a max of 2.20 RMS. We'll see in dB, almost at the limit of, you see, it's almost clipping there. Okay, I can say around 2 volts RMS for a safe input. Okay, that's it. But this is with everything on maximum. If we have everything on 0, so we have 2 RMS input, and then we have 1.5, let's say, volts RMS at output. So there is no amplification. It's even under the signal. I think that's it for today. We can't do more than this. You got the recording on the screen, so you can have your own statistics and numbers, and I hope it's useful. Finally, it turns to be a really nice and interesting tone control with all the tweakings we did. I love this bass, at least, you know, going under 30 hertz, you know, that will bring a lot of how can I say, a lot of bass, you know, deep bass, and that fluffy bass. Okay, I hope it's useful. Please like, subscribe, and of course don't forget to write, and don't forget to have fun. Bye bye.